Welcome everyone to the panel on trends around the Internet of Things, Industrial Internet of Things. It should be a fun discussion, and it's intended to be a discussion. I'm going to introduce the panelists. I have a couple of questions just to get things going, but this session is really truly for you. It's for you to ask questions. We really have some thought leaders in the industry that have a lot of insight into these trends, and so I think you're going to get a lot out of learning from them. So let me introduce each of the panelists, starting to my left here. Paul Didier is from Cisco, and he is a solutions architect manager for Cisco's Internet of Things group. Paul is responsible for developing solutions for discrete and process manufacturing, for transportation and utility verticals. And in addition to his work at Cisco, and we'll get into this a bit on the panel, he does work with a number of different industry consortiums, including the Industrial Internet Consortium, as well as the Open Device Vendor Association. So thank you, Paul, for being here. To Paul's left is Mark Cudak from Nokia Networks. Mark is a principal research scientist at Nokia, and he's part of their North American Radio Systems Research Group. He focuses his research on evolving cellular network standards from 4G and now to 5G, and on building prototypes of real-world networks. Mark is really an expert on every telecommunications acronym you can throw at him. Set him up there. And he has over 40 issued patents, and he will be on the keynote stage tomorrow, correct? Returning to the keynote stage tomorrow. So welcome again, Mark. To Mark's left, DongJin from Hyundai Motor Corporation. He actually leads an initiative a little bit different from what you might expect from what you probably know Hyundai for. He does wearable robotics for elderly patients and disabled people. And it's basically a human exoskeleton. And we're going to talk more about that. It's a fascinating application. And it is also going to be on display on our Day 3 keynote on Thursday. And finally, Greg Gorman from IBM. Greg is the director, really leads the IoT Engineering Solutions group within IBM. And he also is really a thought leader at IBM in areas like complex system development and IBM's corporate advisory board representative to INCOSE, the International Council on Systems and Engineering. And he is a legitimate, bona fide system engineer by background. And Greg will be speaking on Day 2 as well. So you're going to get a preview of some of the things you're going to hear in the next couple of days in the keynotes here at the panel this afternoon. Okay, let me open it up with a couple of questions, and as I said, then I'll turn it over to you. There's been a lot of, as I mentioned this morning, a lot of hype around the IoT, but we also know there's a lot of real value and impact, and hopefully you saw some of those this morning. So I'll start with you, Greg. Where do you see kind of the opportunities to add real value on these trends?
I think this is working, right? You guys got me there. All right. I think there's several big trends that are going along there. There's a lot of convergence, obviously, that's making all of this happen. We're seeing some interesting things in wearable technologies, a lot in terms of elderly care that might be interesting. I don't know, there's so many different places where this is going to apply. You talked about the IIC and Industry 4.0 and being able to do almost instantaneous manufacturing. Sometimes we call it hedonistic design, where I want to design it just for me, have it built just for me, kinds of things, and we'll be able to produce that rather quickly. I think is exciting. And I think that it's just wide open. I don't think our boss or my boss would have spent $3 billion without seeing some kind of opportunity there. And I think we see it across many industries. Almost anything you can think of is applicable to these days. One other example, I guess I'll just throw one in, is service-oriented type businesses where traditionally they might have been just a supplier of a particular piece of equipment, like an air conditioning unit, and now instead they want to be a 72 degrees supplier, and they don't care. Now I'll be like, I just want 72 degrees. I don't care how you give it to me, sort of thing. So I think we're seeing a big trend in that area as well.
Cool. Paul, what's your perspective of Cisco on that point, applications of IoT?
Yeah, I think what I've been amazed at is the industrial companies coming to us and begging us many ways. You know IT, Cisco. We need, let's just start with the most basic connectivity to our machines, our cars, our robots, our factory, equipment, all kinds of ranges of things that they've never had connectivity to. Machine builders coming up to us and say, I built my business models, I build a machine, I send it to a customer, and if it ever breaks, I might send an engineer later. With basic connectivity to the machines, in many ways, nothing radical on bandwidth or other things, just read-type data. They're starting to be able to do zero downtime, asset utilization, asset optimization that are absolutely incredible in terms of the value that they're starting to bring to their customers, but also driving them into utterly new business models where putting a robot on a plant floor is just the beginning of the value stream, not the end of the value stream for many of these guys, where then they can move into service contracts or other things to provide ongoing continuous value to their customers and save themselves, lots and lots of time of sending engineers out into the field, learning a lot more about their product in the field, being able to upgrade it, update it, and drastically improve their own R&D. So Cisco as well is looking at things like trying to get to zero defect on a lot of our equipment. Most of the high-tech industry is still extremely manual. And for us, sending a product out, be it industrial or commercial going into a data center, ever seen downtime on that due to hardware or to production failures is extremely expensive. We have to go, it's downtime to the customer, we have to replace it, do an immense amount of calculation. Why did this occur? Where did it come from? What we're looking to do is get a lot more information out of our contract manufacturers so that we can tell, is our product being built right? What are some of the problems with it? And actually significantly improve, but significantly decrease the amount of time we spend in test. Lots of good business.
So obviously one of the fundamental things when we talk about this whole trend, Internet of Things, is that it's about connecting a lot more things, as the name implies, and not just people. And it puts some different requirements in some of our communication infrastructure. So let's start with the wireless side of that, since we have a renowned wireless expert here. With the rise of more M2M, how is that affecting the way we're architecting next generation 5G networks? Mark?
Well, it's an amazing requirement that we have to look at here. We're projecting 50 billion devices by 2025, more machines than there are user devices. And if you look at today, our networks today will not be able to handle that volume, but we're working toward that. We're trying to understand what the requirements are. And we kind of look at it 3 different ways. We're looking to support the machine type devices. You're going to have ultra deep networks, a way to address multiple devices, many different types of devices, more volume than you've seen today before. We're also looking at ultra dense, so we also have to provide a lot of data rate to some of these devices. Not all machine type applications are going to need a lot of data rate, but some will need quite a bit. So you have to have denser networks providing that higher throughput. And then finally, you have to be ultra reliable. You've got to worry about incidental interference and as well as malicious interference. So these systems have to have that reliability built in. And so when we look at support in cellular networks for machine type devices, we're really looking at two different solutions. One is called LTE-M, that's M for machine type. Another one is 5G, is what's going to address it. And right now there's work already ongoing in LTE release 12 for machine type communication. There's also more work to even make that even better in release 13 for LTE-M. So what that will provide for you is longer battery life for these devices. Our goal is to have 10 years of battery life on 2 AA batteries. And that's quite a lot of details you have to build into the wireless network to support that low power cycle. And then as you move toward 5G, we're looking at lower latency and higher reliability. So LTM will bring you this massive machine type communication, and 5G will bring you mission critical machine type communication.
We can bring that battery life to my phone. That sounds awesome. And then, so Paul, you work on a lot of technologies that are also part of this industrial internet. So talk about some of the areas you're looking at to evolve our networks.
Yeah. So we heard a lot this morning about the industrial internet of things. And internet is that second word there. And somebody from Cisco, we feel like over the last 30 years we've been a very close, let's say, shepherd of internet technologies, helping them get into the markets in first mainframes, and then PCs, and then voice, and then video applications. And our CEO has been very clear. He thinks this is the largest revolution we've seen yet in the internet, and we're actively, let's say, enhancing a lot of these internet technologies. We're not going at it, when looking at the industrial, saying, you have to use the IT version of the internet. We're actively enhancing it. One of the things we're collaborating, especially with National Instruments on, is enhancing IEEE 802.1, the Ethernet. This is the core of internet technologies. And we're enhancing it for industrial applications. We're adding a capability that we're referring to as time-sensitive networks into the standards. It's a range of standards, but they're designed to basically handle a lot of the critical control. We've been very vocal about thinking that by 2020 we'll see 50 billion devices. Well, the only way we're going to get there is start connecting lots of them. And most of these devices in the world today, in a lot of these industrial places, the 85% we saw, are connected through proprietary or local unconnected networking technologies. And we think TSN is going to be a good way to open those up and get to the data in there. What we're doing with TSN is basically adding real-time deterministic characteristics to a much finer degree, adding a lot more, as you said, the reliability, the guarantee of service. So really bringing down the latency, significantly reducing jitter and guaranteeing packet delivery, all while being able to do the telemetry, video, and other networking technologies or networking applications that you would expect, and try to bring that in a secure manner. So across wireless and across security technologies, there's a lot of really good activity to improve these base technologies for this industrial technology. Really excited about this.
Cool. Yeah.